Please introduce yourself and briefly summarize your education and professional background.
Hello, my name's Gavin Lewis. I live in the UK. I work for Fathom for the last 7 years. My background is civil engineering. Although having worked on some very large infrastructure projects here in the UK, I decided to get more into spatial data and technology. So for the last 27 years, I've been working with maps and data and applying them at point of need to governments, engineering companies, infrastructure companies, utilities, Europe and US and globally.
Okay, that sounds perfect. So for those unfamiliar, what does Fathom do? And in particular, can you tell us about its Fathom Flood Risk Index, which I believe is kind of a popular thing?
Yeah, sure. So Fathom has been around for over 13 years now. Started off at the University of Bristol by two PhDs. During their flood research for their PhDs, they felt they could develop much better flood models globally. And that's essentially what we've been doing since then. So Fathom builds and provides flood maps and models to tell you essentially what gets wet at a global scale, but also a local scale. And it's not just looking at what the flood looks like today, but it's also looking at what the flood is going to be looking like under different emission or climate scenarios to the end of the century. So everything we do, because of the academic background, is published in leading peer-reviewed journals. So all our methodologies, all our validation of our data sets, we publish in the leading scientific journals. We publish them in a lot of scientific or academic papers that are all peer-reviewed. And the key thing about Fathom is we're very transparent about our methodologies. We make all our methodologies available to any of our end users, or in fact, all our papers are available on the website for public scrutiny. So we are very transparent and encourage people to read and understand the way we build our models, because we believe that's the only way to work. When people are new to us, they are making invariably very valuable decisions, potentially based on our data. So they've got to have the confidence and the evidence base that the data they're using from Fathom to make those decisions is grounded in solid, transparent science.
Okay, thanks. So it sounds like Fathom does mostly public work for public websites and for providing general information out there. Do you ever work, privately with clients to help, work on
Yeah.
specific tasks that they request?
Yeah, so a lot of our work is actually in the private domain. We do a lot of public work. We have the Canadian government use our data to give the government's perspective of flood risk nationally across the country. But we've done a lot of work with other organizations, utilities in the US, as well as water companies and transportation companies in the US and globally using our data. But we also grew up in the insurance industry, so our data is used for pricing and underwriting flood risk. It's used very heavily in the financial services market, looking at acquisitions, investments, and capital markets. So we have a very broad base of users for our data.
Okay, so let's talk about the important part, that being the data. So can you tell us a bit about your models, how they were developed, who they're geared toward, and what they can be used for?
The models effectively are built on a 2D modeling platform called ListFlood. Essentially, this represents the flow of water across the Earth's surface. So this is a much more sophisticated flood model than some bathtub models that are out there. So we take all the river channels, we build that into our model. So we represent the flow of water through river channels and also across the floodplains. So we base that on open source data. So of course, in the US, you've got wonderful open source data, both terrain data, river gauge data, and rainfall data. And we pull all that into our modeling environment, and we effectively develop flood models or flood maps for the river flooding, surface water or pluvial flooding, and also coastal flooding. In the US, that's done at 10-meter resolution. And globally, that is at 30 meter resolution. So we have everywhere in the world mapped for flood risk. And that's not just today's perspective of flood risk, that is also looking at what's going to happen to flooding under different emission or climate scenarios out to 2100. So we can give a perspective of what the flooding looks like today, but also what it's going to look like in 2050 or 2080. Now, where is our data used? It's very much used at the sort of early stage projects where people really want to understand where the problem areas are. That could be location of assets, that could be data centers, that could be substations or pumping stations or housing development, or it could be linear assets where you're looking at very thin corridors extending over vast lengths. So our data really, it can be accessed very quickly through APIs to pinpoint the problem areas to say, okay, actually, what type of flooding is it? Is it river flooding, flash flooding, or coastal flooding? What's it going to look like today? But also under the term of the life cycle of that particular asset, whether it's 20, 30, or 50 years design life, but also that then signposts very quickly where the problem areas are. So a lot of our clients, the large engineering companies like the WSPs, the ACOMs, the Arcadis, Jacobs of this world, use our data to identify the problem areas at early stage of projects, and then they use that as an evidence base to then develop their own much more detailed flood models using HECRAS and 2Flow and other modeling platforms to get that very nuanced detailed flood modeling. Our position at Fathom is to signpost and guide people to where the problems are so they can then do the more detailed modeling. Now, in the US, of course, you've got some great data in FEMA, but our data really complements FEMA and it fills in a lot of the gaps. There are a lot of states and cities and towns that don't necessarily have FEMA data. And where they do have FEMA data, invariably that's not often up to date. So we provide that consistent view of flood risk across the whole of the country and the US at a high resolution. But in addition to that, we also are able to say the different types of flooding. So with FEMA data, it's either coastal data or river flooding. There's a lot of flooding that occurs due to surface water or flash flooding. And so we're able to identify those areas as well, where FEMA has just the major river channels. We have all the river channels across the US mapped in our data set. So we're able to provide a much more nuanced and detailed assessment of flood risk, both today and in the future.
Okay, thanks. That's a great background. You talk about being able to model into the future, and I've heard a lot of it that one of the biggest problem in flood modeling now is all of these data models that have been used historically that were accurate for decades are no longer, hardly accurate at all. How are you guys working with that problem of how the things that were historically, accurate are kind of out the window right now? What are you guys doing about that?
Yeah, so historic record doesn't necessarily give you the same view looking forward. So we have to build certain levels of uncertainty in our models, and we bring in an ensemble of global climate models, and we choose the best models that best represent changes in precipitation at a global scale. So we're very nuanced about the models we choose, and we apply a series of change factors to those. And the thing is, with climate change and flooding, some people assume that it's kind of going to get worse everywhere. That's not the case. There are some areas that actually the flooding is not going to get as bad, or it's going to be a different type of flooding. So obviously, in coastal areas, you're going to have an impact of sea level rise, but that's already baked in. That is already occurring, and that's going to continue to occur. Whereas some areas may get drier and have less frequent but more severe flooding than they're exhibiting today. So it varies depending on where you are, both in the US and ultimately globally. So there's some areas are going to get a lot worse. Some areas actually might get better, but it's through the modeling that we do, we take into consideration a lot of that uncertainty, both in the model uncertainty, the historic model uncertainty, but also the forward projections. So we give views of our flooding at one level of uncertainty, but then also band that to higher and lower percentiles. So you can actually get a much more nuanced and detailed understanding of that impact of flood risk today and going forward in time.
Okay, that makes sense. But can you just, obviously you need to, explain that it is harder to be certain about your models, but can you project, comfortably with just allowing that, hey, it's more difficult to be 100% sure, or do you just have to just say that it's really difficult to do this now, or how does that work as far as the
Yeah.
the
So we
security and what the data you're providing nowadays?
Yeah, no, it's a good question, and it's something we get asked quite a lot. We effectively are giving a view today, and we're pretty certain around what that looks like. But of course, the further out in time you go, that view becomes less certain because there's a greater level of uncertainties in there, which is why we provide different views to our end users to say, okay, this is what we think is going to happen. These are the areas that are going to get wetter. This is the depth of inundation. However, we put a levels of uncertainty between, and those levels increase the further out we go to 2100. So end users can actually make a much more informed decision around that uncertainty and build that into their decision-making process. It's better that we flag that there is uncertainty in the outputs and the level of uncertainty rather than giving a binary outcome where they've got no understanding of the methodology and the transparency of that, but also, has any uncertainty been built into those models? And in fact, what type of uncertainty has been built in? So it's clearer. We're trying to provide a much clearer understanding to our end users around that uncertainty and how that's going to ultimately impact the answers and that they're seeking in their analysis.
Okay, I've got a question in your personal role. Now you're a civil engineer and the head of engineering there at Fathom. How do you approach things as an engineer as opposed to a hydrologist who looks at the data of water? And do you and bring in a lot of other types of scientists, or is this more an engineering focused kind of a model?
It's very much a physical based model where there's a lot of science associated with that. But my role is dealing with fellow engineers and trying to interpret the science and bring that to bear to make more informed engineering decisions, whether that's around protection of a specific asset, could be a data center, or actually taking a more holistic view where we're looking at, okay, if we could, so we provide the understanding around the flood risk of the assets, so we can give a good indication of the size or the value of the problem of flooding. It's then working more holistically to say, okay, if we know these areas flood, we can look at developing some very straightforward, grey infrastructure to make protection of those assets. But actually, how do we take a more holistic view, looking at things like nature-based solutions or a blue-green infrastructure to say, how do we actually make, rather than just these particular assets, but more at a community or a regional level, make these implications to provide the level of protection, but actually provides wider benefit to the communities or the people that live there at large. So I think that's why we're trying to give much more detailed and nuanced evidence to feed into those types of discussions. And a great example of that is the work we've been doing with the Texas Water Development Board, where we model specifically the whole of Texas for the Texas Water Development Board. We worked with a state climatologist to get the right level of future scenarios around climate change. And that data is now with the 15 regional flood planning groups out in the communities. And a lot of these regional flood planning groups have never had proper flood maps before. So this is the first time they've really understood the impact of flooding. And that is feeding into a statewide initiative to make the state more robust and more resilient to the types of flooding that they had through Hurricane Harvey, which impacted the state dramatically. So it's not just telling you what gets wet, it actually has much wider implications to add, in this case, up to a state level for the benefit of using the data that we created.
Do you think that having this kind of engineering focus toward flood modeling kind of makes Fathom a little bit different as opposed to some of the science-based, the FEMA, the floodplain mapping that's more just watershed based? I think because you're focusing on assets and the impact, that makes a difference.
I think there's a lot of core principles that we're using that, all flood modeling comes from the same place. But we're applying a much more scientific view in that, and we're bringing that combination of deep science and understanding and transparency to that engineering model. So, we're working with the larger engineering consultancies to provide them that understanding to help them work with their clients either at a federal, state, a local level, or on the commercial side to help apply the right protection for those particular assets. But I think it's very much scientific driven. So, there's a lot of correlation between the models that we have and the models that FEMA have developed, although our science is very much at that cutting edge, and we're constantly investing in pushing the science forward. Later on this year, we'll be revealing our new global hazard data set. And underneath that, underpinning that, is a huge amount of science and investment in new developments that allow us to get a much greater level of granularity for flooding at a local, regional, and national scale.
Okay, speaking of these scales, a lot of the talk of flood risk is considered a coastal problem with rising sea levels and such. But I believe you guys state that it's actually the inland areas, the inland states that are more at risk of flooding than these coastal areas. Can you explain that and why?
So with coastal areas, people are living by the sea. They're seeing the impact of the changing weather patterns, and have an understanding that actually inundation, flooding due to sea level rise and king tides is something that is only going to increase. But a lot of areas inland in the US that traditionally have not had flooding or have not been identified as flood regions in the FEMA data, there is a potential lack of understanding that actually there are significant areas across the US that could be impacted by both river and flash flooding that aren't necessarily picked up in the FEMA data. We did some work comparing our data to FEMA's using population data by the EPA. It's a paper we published a few years ago. And through the flood maps that FEMA produced, there's about 15 million US citizens exposed to flooding. Through the Fathom data, because it's much more granular and consistent, there was about 45 million US citizens that were exposed to a 1 in 100 year flood. So it's actually a part of it is around the data that's available for people to use and make these decisions on. And we're actually building onto the FEMA data that people have been using for many years to say, actually, our data complements that, but actually gives a much more consistent and detailed view of flood risk, which is why people are seeing that actually by bringing the Fathom data and the FEMA data together, they are identifying new areas that are at flood risk that perhaps weren't identified in the FEMA data, and now they need to make judgments and investment to raise those levels of protection or adapt their lifestyles to accommodate that.
Could you describe maybe one specific example of how that is the case? Like perhaps like one area, one town, one thing that you found that they can kind of provide a fuller picture of what you're talking about?
We have done, as I mentioned, quite a lot of work in Texas, where there are some very big rivers, very major rivers that have been mapped and modeled by FEMA over many, many years. And those models are very detailed, they're very accurate, and they're very consistent. However, outside of those major river areas, major river channels, there is a lack of detail for that FEMA doesn't capture any of those river channels or the flash flooding. So a large proportion of the flooding, certainly in the mid and northern Texas, is down to flash flooding. And through the work that we're able to do with the Texas Water Development Board, was essentially able to identify those additional areas that were impacted by flash flooding. There was a significant proportion, probably at 40 or 50% more flooding that was identified through these new maps than was identified through the FEMA data sets where they existed. So there's a significant uplift in the areas that were impacted by flooding that were identified as part of this process.
I think it's a nice little detailed example. I appreciate that. So I like to do a lot of advice in these little interviews. So what do engineers need to know about the increasing flood risk as they design their own infrastructure projects, and which type of projects are most vulnerable, and how can they, think about this to do better work?
based on the insurance industry, when insurers make a view on risk, they have what they call a blended view. They just don't take one view of risk. They try and get as many views of risk as possible to make those informed decisions. And I think that's really important for engineers, is rather than relying just on the FEMA perspective of flood risk, they need to take a more nuanced and blended view of risk to say, okay, what are the other data sets out there to give me a much more balanced and consistent view of flood risk today, but also in the future. What's going to happen if I'm designing infrastructure that's got a life cycle or design period of 30, 40, 50, 60 years? We need to ensure that what we're building today is going to be future-proofed. So by having the full information, a consistent picture, whereas FEMA, you might be only getting 50% of the picture of flood risk. With the Fathom data, you're filling in those gaps, you're getting a much better, consistent view of flood risk. Then you can start making your decisions. Okay, how much do we need to invest in developing and protecting our asset, both today and under future climate scenarios? So it's making sure you've got the best evidence and the to hand to make those decisions, but also thinking about that future view as well. Coming back to your question around most vulnerable assets, of course, flood is ubiquitous, and all flooding is very local. So you've got to have very detailed information to identify where that flooding is. But, obviously, properties that are identified in floodplains are going to be really vulnerable. But then when you're looking at linear infrastructure, that you've got whether that's road or rail, or it could be energy infrastructure, then those assets invariably are going to be impacted by flooding across that whole network. So we're doing a lot of work with utilities and asset owners at a network level to identify the pressure points of flooding, both today and in the future, to make sure those networks are resilient. But then you're overlaying things like criticality. So if your critical infrastructure is going to be impacted by flooding, you maybe want to look at protecting those more than some of the less critical infrastructure. So it's getting that balance really on not only an asset protection, but also the criticality of that asset and how that integrates into your network of assets, or whether that's distribution or transportation going forward.
As they're trying to apply these engineering best practices, now that things are where they are, is trying to make infrastructure more resilient kind of the main, if not the only option to prevent flooding damages, or other ways that they can engineer to try and avoid flood risk in the first place? Like, is it too late to try and decrease the amount of flooding that's out there? Or do you look more like where you can and cannot build? Like, is it more resilient, or are there other things that they can do?
So I think there's you start off at a base to say, okay, what does the flood problem look like today? And if we're going to develop this area, what's that going to look like in the future? But it's looking at that potentially holistically to say, okay, well, I've got my particular asset, I need to make that resilient, whether that's an existing infrastructure or new infrastructure. But if you're able to take more of a holistic view at a county or a state or at a potentially a national level to say, okay, well, how do we mitigate the impact of flooding for this particular location? How can I work with the community? How can I work with other agencies to offset or reduce or mitigate or delay that flood risk? Do we actually, rather than the water coming all the way through the flood channels, do we store that water? Do we retain it for leisure or recreation purposes? How can we use this as an opportunity to enhance some of the areas? And we're doing some work in the Middle East at the moment for a large energy company that is looking at retaining and harvesting rainwater and using that for a whole range of different energy, recreation and social amenities, and really taking a totally different view of how people treat water, rather than just pushing it out and letting it run out ultimately to the sea, to perhaps retaining it and using it for other purposes. So I think it's much more of a holistic view where we're bringing lots of interested parties, but all of that starts with the core understanding and the evidence base to say, okay, what is the impact? What's going to get wet? How deep is it? What's that going to look like today, but also in the future?
I think that's great. I like that people could look at things holistically and get the community involved, because it's not just the assets and the owners there that are at risk. Flooding is a wide scale problem. So I think that's a great way to
Indeed.
look at it.
We talked about the new data sets coming out. There's a lot more science that we're building into what we're doing. And it's not just flood maps. We have taking vulnerabilities of buildings and developing catastrophe loss models. So rather than saying hazard and risk, what gets wet and how deep, we can actually now calculate the financial losses due to flooding, both today and in the future. So there's a lot more that can be brought into this discussion with asset owners, infrastructure managers, and engineering consultancies to get a much better handle of risk both today and in the future, and take that to calculating losses and getting more into the financial modeling of flooding, which is we're really just scratching the surface on that. There's so much more to do in that area as well.